Welcome to the next session, my dear friends. In the previous session we have discussed about the up to the question number 10. So we are going to continue those questions now. So let us discuss the question number 11. Question number 11, GATE 1996. GATE 1996, 1 mark. So the question is like this: the main constituents of gas generated during the anaerobic digestion of sewage sludge. So during the anaerobic digestion, the gases that are generated are CH4, so this is 70%, and CO2 20 to 30%, and H2S and other gases in traces. So this is what we have learnt. Okay, so from the options, look at the options: carbon dioxide and methane. The first option, methane and ethane. Second option is wrong. Carbon dioxide and carbon monoxide, that is also wrong. Carbon monoxide and nitrogen, that is also wrong. So the option is carbon dioxide and methane. That is the answer. That is the answer of question number 11. Question number 12. In aerobic, GATE 2005, 1 mark question, question number 12. So this is for anaerobic digestion. Here in aerobic environment, the nitrogenous, that means nitrogenous organic matter will convert into, so in aerobic environment, generally we will be having plenty of oxygen available in aerobic environment. That is what we assume. There will be plenty of available oxygen. So whatever the compound that will form will be stable compounds. During aerobic decomposition, stable compounds will form. So stable compound means they are completely neutralized. They don't carry any kind of charge. So if you look at the options, so except A and C, rest of the two options, they are carrying a negatively charged compound in it. So B and D we can eliminate. From looking at from looking at A and C, see here oxygen is plenty. So the end products will be having a extension called AIDS. So when we are having a plenty of oxygen, so the compounds will form in the terms of AIDS. That means nitrite, oxygen deficiency; nitrate, oxygen is sufficient; sulfide, oxygen is deficient; sulfate, oxygen is sufficient. So AIDS means oxygen is plenty. Okay, so in the options generally we look the options where the oxygen is plenty. So if you look at the first option, it is ammonia to nitrate. So whatever the aerobic environment, free ammonia NH3 is the organic matter. This will be converted into a stable organic matter which is AIDS. That is what we have learned. Free ammonia will become albuminoid nitrogen. Albuminoid. In the water supply we have discussed this. It will become albuminoid nitrogen or organic nitrogen, and then it will convert into nitrite. And last it will convert into nitrate. So nitrate is nothing but NO2. So NO2 is nothing but nitrate. Okay. It is the answer is ammonia, free ammonia will convert into nitrates. That is the answer. That is the answer for the question number 12. Question number 13, GATE 1992, 1 mark question. GATE 1992, 1 mark question, question number 13. Question number 13. Trickling filters are used to remove. Trickling filter, generally trickling filter is a secondary treatment unit. Secondary treatment unit. We use the secondary treatment unit to remove the organic matter, not the suspended solid, not the colloidal solid. Suspended and colloidal solids will be removed in the settling tanks, not in the secondary treatment units. So secondary treatment units, generally they reduce the organic matter with the help of bacteria or microorganisms. So that is why here in trickling filter, so what we will remove the organic matter. So organic matter is the answer. Okay. So let us discuss the next question. Question number 14, 1995, GATE 1 mark. 1995. GATE 1995. One mark question. Question number 14. So let us read the question. A trickling filter is primarily A. First option, straining process to remove the suspended solids from sewage. B. Biological oxidation process to remove BOD from sewage. Option C, straining process to remove turbidity. Option D, straining process to remove bacterial from the water. So, trickling filter is a secondary treatment unit. A trickling filter is a secondary treatment unit used to remove organic matter, or BOD, organic matter, or used to remove organic matter or BOD with the help of microorganism or with the help of aerobic bacteria, with the help of aerobic microorganisms, that is the work of the trickling filter. So it is a biological oxidation process. Okay, it is a biological oxidation process to remove BOD from sewage. That is the answer. So question number 15, GATE 1996. GATE 1996, 1 mark question. Question number 15. The removal of dissolved organic matter occurs in. So here the removal of dissolved organic matter occurs in. Option A, slow sand filter. Option B, trickling filter. Option C, rapid sand filter. Option D, dual media filter. See, the three filters what we are seeing, slow sand, rapid sand and dual media filter. So they are used to remove the colloidal particles, okay, to remove the colloidal and dissolved particles, but the organic matter which is in the soluble form, I told you, in the secondary treatment we use unit process. We use unit process to remove the soluble BOD present inside the water, wastewater. So, in secondary treatment, treatment, we remove the soluble means what? Dissolved. The soluble BOD present in wastewater with the help of microorganisms. So generally we remove the soluble BOD. Soluble means what? Dissolved organic matter. So if you look at the options, all the three, slow sand, dual media and the rapid sand, these are all, they removes the colloidal particles, okay, or some kind of dissolved particles which are in inorganic nature. So organic matter, they cannot act with the organic matter. Organic matter they will remove to some extent, but trickling filter is a device which is dedicatedly working on the removal of organic matter. Okay, removal of organic matter. So that is question number 15. Question number 16, GATE 2002. GATE 2002, 1 mark question. GATE 2002, 1 mark question. A trickling filter is designed to remove. Here also the same question. Settleable solids, colloidal solids will be removed by in the normal filter or in the sedimentation tanks. But dissolved organic matter is removed in trickling filter. So here the same question again repeated. So dissolved organic matter. So dissolved organic matter is removed in trickling filters. Okay. Not only trickling filter, it may be activated sludge process, it may be sludge digestion tank, it may be any secondary treatment. All the secondary treatment will work on the dissolved organic matter only to reduce the dissolved organic matter. That is the work that happens in the secondary treatment of wastewater. Okay. So let us go to the next question. Question number 17. Question number 17, GATE 2003. GATE 2003, 1 mark question. Question number 17. Question number 17. So the question is like this: which of the following sewage treatment methods has inherent problems of odor, ponding and fly nuisance? See, odor, so problems, what are the operation problems? Operational problems are given. So what are the three operational problems? Odor, ponding and fly nuisance. So to which treatment unit these three operational problems we have discussed? To which treatment unit these three operational problems we have discussed? We have discussed it for trickling filter. We have discussed this for trickling filter. So right, so these are the operation problems of trickling filter. So the option C is the answer. Option C is the answer. Question number 18, GATE 2014. GATE 2014, 1 mark, set 1. 1 mark, set 1. So the question is like this, is question number 18. Question number 18. The amount of CO2 generated in kg while completely oxidizing 1 kg of CH4 to the end product. So here we are oxidizing CH4 to its end products. So here generally in the absence of oxygen we have generated CH4. So that is why it is having oxygen deficiency. Why it is combustible? Because it still needs oxygen. That is why it is having energy value. If you are having completely filled with oxygen, your energy value will go down. So it is having deficiency of oxygen. It needs oxygen. It is oxidizable. So if you give oxygen to it, so it will become CO2 plus H2O, 2H2O. So here 2 oxygen is needed, here 2 oxygen. So here I need 2 molecules. 2 moles of oxygen is needed. 2 moles of oxygen is needed. Now what he is asking? He is asking what is the total weight of CO2, amount of CO2 generated in kg when 1 kg. So here what is the molecular weight of CH4? C12 plus H4, that is 16 gram. So 1 mole is nothing but 16 gram. 16 gram will give how many grams? 12 plus here it is oxygen is 16 into 16, that is 32. So that means it is 44. So 16 gram is giving 44 gram. So 1 kg will give, so 44 by 16 into 1 kg. So this is the CO2 generation. So this is the amount of CO2 that will be generated. This is the amount of CO2 that will be generated, which is equal to 2.75 kg. 2.75 kg. So for 16 gram we are generating 44 gram. For 1 gram 44 by 16. For 1 kg 44 by 16 into 1 kg, that is 2.75 kg. That is the answer. Next is question number 19. GATE 2019, 2 marks, set 1. These are all very, very simple questions, small questions. GATE 2019, two marks, set 1. GATE 2019, 2 marks, set 1. A 0.8 meter deep bed of a sand filter, length 4 meter and width 3 meter, is made of uniform particles. Diameter is equal to 0.40 mm, specific gravity is equal to 2.65, shape factor is 0.85, with bed porosity is 0.4. The bed has to be backwashed at a flow rate of 3.6 meter cube per minute. During the backwashing, the terminal settling velocity of the sand particle is 0.05 meter per second. The expanded bed depth in meter. So this is actually question relevant to rapid sand filter, but it was came here. Anyways, let us solve this here itself. So what is the given data? What is the given data? So bed depth is given, okay, length is given and width is given. So length is L is equal to 4 meter and width is 3 meter. Width is 3 meter and depth 0.8 meter. Depth is 0.8 meter and the diameter of the particles, dia of particle D is equal to 0.40 mm. D is equal to 0.40 mm. Specific gravity specific gravity S is equal to specific gravity S is equal to 2.65 and shape factor phi is equal to 0.85 and bed porosity n is equal to 0.4 and the bed has to be backwashed at a flow rate. So it is the flow rate of backwashing. So flow rate of backwashing so that is QB is equal to 3.60 meter cube per minute 3.60 meter cube per minute. During the backwashing, if the terminal velocity was given, terminal settling velocity, so terminal settling velocity that is Vs is given. Vs is equal to 0.05 meter per second. 0.05 meter per second. This is Vs. Now, what is the expanded bed depth? He is asking expanded bed depth, that is ZE, is how much? Okay, expanded bed depth he is asking, that is how much? Okay. So now first of all we need expanded bed depth. So how to find the expanded bed depth? If you know the normal bed depth, see we have already learnt this in our rapid sand filter. So there is a relationship we have derived, that is ZE into 1 minus NE is equal to Z into 1 minus N. This relationship we have derived in the rapid sand filter topic of water supply engineering. So now he is asking ZE. So ZE is equal to Z into 1 minus N by 1 minus NE. Simple. So if you look at the depth of the bed, so depth of the bed was given. So this is the depth of the bed. So this is nothing but Z. Okay. Porosity is given. So we want only expanded bed porosity. This expanded bed porosity we want. So now come back. What is the formula that is there to find the expanded bed porosity? There is a formula I have told you. Expanded bed porosity is equal to VB by Vs whole to the power of 0.22. This formula we have learnt, where Vs is terminal settling velocity. Vs is terminal settling velocity. So that is present. So terminal settling velocity, that is already there. That is equal to 0.05 meter per second. So Vs is there. So we want Vb. Vb is nothing but rate of backwashing. Vb is nothing but rate of backwashing. So that is nothing but, so you want rate of backwashing meter per second. Here if I multiply it with surface, if I divide it with surface area, then I will get the rate of backwash or backwashing velocity or velocity of backwash. Velocity of backwashing. Now, so this velocity of backwashing is nothing but Q by surface area. Q by surface area. So Q by surface area is nothing but Q by B into L. So this is also given here. So Q is how much? 3.60 meter cube. So per minute I will convert it into seconds, that is by 60. Then it will become second. So the area is 4 into 4 meter into 3 meter. Now it is becoming, so meter cancels, it will become meter per second. So this is the VB value. So what is the VB value? We will get here 0.005. 0.005. So this is VB value. This is VB value. Now here we know VB, that is 0.005, and we know VS 0.05. Both are in meter per second only. Both are in meter per second. Now we can find the expanded bed porosity. So what is the expanded bed porosity? From here we can find the expanded bed porosity, which is equal to 0.60255. 0.60255. This is the expanded bed porosity. Now we know the expanded bed porosity, that means ZE is equal to, Z means 0.8 into normal porosity. What is the normal porosity? 0.40 by 1 minus expanded bed porosity, that is 0.60, approximately 0.60. So if you calculate that, you will get the expanded bed porosity, which is equal to 1.21 meter. It is 1.21 meter. Okay, it is equal to 1.21 meter. This is the expanded bed thickness. So that is what he is asking. That is what he is asking in the question number 19. Question number I didn't take in here. Question number 19. This is question number 19. Okay, this is question number 19. So let us go to the next question. Question number 20. Question number 20. Gate 1993. So lot of data is given which we haven't even used it. Sometimes in the question they will give you lot of unnecessary data. By looking at the data you will feel panic. So this much big question it was. So it is not possible for us to do like that, we will think. Whenever you feel like it, keep that question to do at the last of the examination when you are having plenty of time. First attempt the questions which you are feeling comfortable, and then go to the question which you feel little tough but you can do. So gate 1993, 1 mark. Question number 20. Activated sludge is. Activated sludge means what? I have already told you in the class. Aerated sludge in the aeration unit? No, we take the activated sludge from the secondary sedimentation tank. Second option is sludge settled in the humus tank, that is also wrong. Third option, sludge in the secondary tank after aeration and rich in microbial masses, very correct. So this is exactly what we have explained. So in the secondary sedimentation tank, the biomass will be more. The more number of microorganisms will be present. So that is called activated sludge, which we take back into the aeration tank. That is activated sludge. So option number C, sludge in the secondary tank after aeration. Okay, that is the answer. Sludge in the secondary tank after aeration, which is rich in microbial concentration. This is the answer. Okay. So that is question number 20. Question number 21. GATE 1999, 1 mark. GATE 1999, 1 mark question. Question number 21. See here, chlorine is sometimes used in the sewage treatment. Chlorine is sometimes used in sewage treatment to avoid flocculation, to increase biological activity of bacteria, to avoid bulking of activated sludge, to help in grease separation. See, where we added chlorine, if you see in the bulking of the sludge, chlorine is also one of the remedial measures. Chlorination is also one of the remedial measures in order to reduce the bulking. So chlorinating or chlorination is a remedy to prevent bulking of the sludge. Because why bulking is happening? Because more microorganisms, less food. More microorganisms, less food is there, the nitrogenous matter is being consumed by the organic organisms because no food is there. So they will consume the nitrogenous matter within the system. So if you reducing the microorganism, then the bulking you can control. How to reduce the microorganism? By killing it. So by chlorinating it, we can kill the microorganism, we can reduce the bulking of the sludge. So that is why chlorination is a remedy of bulking of the sludge. Okay. Question number 22. GATE 2000, 1 mark. These are very simple questions, very scoring questions for GATE examination. Question number 22. Critical factors for the activated sludge treatment process. Critical factors for the activated sludge treatment. Option A, maximum hourly flow rate. Option B, maximum and minimum flow rate. Option C, maximum hourly flow rate and maximum daily organic load. Option D, maximum hourly flow rate and minimum daily organic loading. So, which are the important critical factors? See here, whenever we design the treatment units, that means wastewater treatment units, during the design we assume that the influent which is coming into the secondary treatment unit is directly coming from the primary sedimentation tank. But into the primary sedimentation tank, which flow will enter? The dry weather flow will enter. So generally, if you take the dry weather flow, peak dry weather flow, so we are having different dry weather flows. Maximum daily dry weather flow, minimum daily dry weather flow, maximum hourly dry weather flow, minimum hourly dry weather flow. I told you for which flow we design, generally we design the sewers. So what flow we are designing the sewers? From the sewers, the sewage will enter into the primary, secondary and tertiary treatment units. So that means whatever the sewage that is coming is nothing but the maximum hourly is the worst. So critical. So when the system will be critical, when the maximum sewage is entering into the system, then the system is critical. So maximum sewage means when it will come, the maximum amount of sewage among all the different maximums, maximum hourly is the peak. Okay, maximum daily, beyond maximum daily, maximum hourly will be there. So that is a maximum hourly is the largest possible sewage that can enter into the treatment unit. So that is a critical factor. And another critical factor is organic loading. So when the organic loading is minimum, how it will become critical? When the organic loading is maximum, then it will cause a criticality in the system. So that is a maximum hourly flow and maximum daily organic load is the critical factors for the activated sludge treatment process. So that is the answer for the question. Maximum hourly flow rate, maximum hourly flow rate, and maximum daily organic load. So these are the critical factors in the activated sludge treatment. Settling test on a sample drawn. Question number 23. It is 2 marks question. Let us see. Question number 23. Question number 23. GATE 2003, 2 marks. GATE 2003, 2 marks question. Settling test on a sample drawn from aeration tank. Settling test on a sample drawn from an aeration tank liquor of ASP MLSS is 2800 mg per liter was carried out with 1 liter sample. The test yielded a settled volume of 200 ml. Okay, the sludge volume index, very simple question. I thought it is a very big question. So what is the given data? What is the given data? So MLSS was given, MLSS concentration. MLSS concentration, that is equal to X is equal to 2800 mg per liter. Okay, is carried out on 1 liter sample. The test yielded settled volume is how much? It is 200 ml. It is 200 ml. Then what is the sludge volume index? What is the sludge volume index? Okay, so sludge volume index is nothing but we are having a formula for sludge volume index using the MLSS, that is, see here, what is the unit of sludge volume index? ml per gram. So ml per gram is the unit. ml per gram is the unit of the sludge volume index. So we have taken 1 liter. So in 1 liter, so what is the milligram present? So this is for per liter he is telling. MLSS is 2800 mg per liter. If I am taking 1 liter of MLSS, what is the weight of MLSS? 2800 milligram for 1 liter solution. So this is the weight for 1 liter, this is the volume for 1 liter. Weight, volume by weight. That means 200 is the volume ml. Weight I need to take it in grams. That means 2.8 gram. So this is the answer. 200 by 2.8 gram. 200 by ml mg per liter ml per gram. Yeah. So what is the answer of this? What is the formula of sludge volume index? Sludge volume index, it is equal to 71.4. So the solution given in your solution sheet is wrong. This is 71.4 ml per gram. This is the answer. Okay, this is the answer, sludge volume index. So let us go to the next question, number 24. Question number 24. GATE 2004, 2 marks. GATE 2004, 2 marks question. Question number 24. So let us read the question. An analysis for determination of solids in the returned sludge of activated sludge process was done as follows. A crucible was dried to a constant mass of 62.485 gram. 75 ml of well mixed sample was taken in the crucible, and the crucible with the sample was dried to a constant mass of 65.020 and the crucible with the sample was dried to a constant mass of 65.020 gram in a drying oven at 104 degree. The crucible with the dried sample was placed in a muffle furnace at 600 degrees centigrade for an hour, and after cooling, the mass of the crucible with the residues is 63.145 gram. Okay. Then what he is asking? Let us see. The concentration of organic fraction of solids present in the returned sludge sample. The concentration of organic fraction of solids. So what is the given data? Let us see first. So weight of the dry sample without oven drying, just simply weight of the dry sample. So this is the weight of the dry sample, that is 62.485 gram. Okay, this is the weight of the, or mass, we take it as mass of the dry sample. And 75 ml of well mixed sample was taken. So the volume of this is 75 ml, and oven dry weight, so weight of oven dry, mass of oven dry, that is 62.65, the sample dried to a constant mass. So this is the weight of the oven dry. So mass of the oven dry is 65.020. Okay, at 104 degree, and mass of the muffle furnace is 63.145 145 at 600 degrees. So what he is asking? The organic fraction of solids. Organic fraction of solids in mg per liter. In mg per liter is how much? See, generally when we are heating it at a temperature of 600 degrees, then all the organic matter will leave the system. So this is weight of the empty, tear weight of the, this is the tear weight, so empty weight of the whatever the pan you have taken, okay. So that is crucible, he is saying that. So this is the empty weight of it, and this is the with the sample oven dry weight at 104 degree, with the sample under muffle furnace at 600 degrees. So the difference, so when we are heating it at a temperature of 600 degree, then all the organic matter will go away from the material. So this difference is nothing but the organic fraction, that is in gram. And what is the volume of it? That is 75 ml. So this difference in gram by volume is nothing but the concentration. So 65.020 minus 63.145 into 10 to the power of 3, that is milligram, by 75 ml into 10 to the power of minus 3 liter. So this is the concentration, that is 1.875 into 10 to the power of 3 by 75 into 10 to the power of minus 3. This is milligram and this is liter. So that is coming around 25,000 milligram per liter. 25,000 milligram per liter, this is the answer. Okay, so we have discussed up to the question number 24. The rest of the questions up to question number 43 we will discuss in the next class. Thank you so much.